Hey everyone, welcome back to our statistics class notes. We're now on page 117, example 144. And right now we're in section 8.1, and we're learning how to understand hypothesis testing. We're building it up. And right now we're trying to understand how to write the null and the alternative hypotheses. So we're in the hypothesize step. Remember, there are 4 steps. You hypothesize, then you prepare, then you do your computations to compare, and then you do your interpretations. So we're really in that first step, learning how to write our hypotheses. So in 2015, this is a global warming example, it was reported that 55% of Americans stated that they believe that global warming is caused by human activities. In 2017, 68% of those responding to a Gallup poll believe that global warming is caused by human activities. So what we're doing here is we have some information from the past that 55% of Americans believe global warming is caused by human activities. 2 years later, we got a poll that says 68%. We want to know if the information from that poll, 68%, is enough information so that we can infer that the population of all Americans percentage who believe that global warming is caused by human activities has gone up. Okay? Assume that the sample size for the 2017 poll was 1,000. Can we conclude that the percentage of all Americans who believe that global warming is caused by human activities did indeed increase from 2015 to 2017? So there's a key word we're looking for. Remember, we're looking for like change, increase, or decrease. So the year representing the sample here is 2017. This is when we got the 68%. This 2015 we're assuming is the truth from the past. Okay, the percentage in 2015 is considered a parameter then, not a statistic, while the percentage in 2017 is the statistic from a sample that we just did if we were back in 2017. So the sample statistic, 68%, that's p hat, and the sample size is 1,000. Okay, so we will need that kind of information as we're moving forward, but I'm still working on trying to get you to understand how to state your hypotheses. So for the null hypothesis, H naught, we always write P equals something. So we're assuming that P equals 0.55, that's 55%, from our information back in 2015. We assume that's the truth. Then we want to set an alternative hypothesis. We want to know if all Americans' thought process has changed on this, and it's up to 68% or somewhere around there. The alternative then is we want to see if it's increased. So in other words, is P now greater than 0.55? That's the research hypothesis. That's what we're intending to try to statistically demonstrate is likely true. Okay, now the test statistic is what we're going to use. So p hat is something that we need. That essentially is our test statistic, but what we need to do is convert that to a z-score. So the test statistic compares our observed outcome with the outcome we would expect to get if the null hypothesis is true. So how do I convert our p hat? Observed value is p hat to a z-score, is to take that observed value, p hat, minus the null value, which is what we assume it to be. So that's p naught, divided by the standard error. Now the standard error we'll see on the next page is computed using p naught, because that's what we're assuming is the truth. So this standard error we'll see on the next page is the square root of p naught times 1 minus p naught divided by n. All right, now if that test statistic is far away, we get a big z value. It's far away from p naught. We would expect if the null hypothesis is true, then we would be able to reject the null hypothesis and conclude the evidence supports the alternative hypothesis. So remember, we're always going to reject or do not reject the null. And then we'll either support or not support the alternative. That's how we're going to always do our interpretations.